Hi everyone, Andres here from ProventusNova. We are ready to start this new series on YouTube for Yocto. The idea is we want to teach you guys how to create your own custom Yocto distributions, and so we can also learn a little bit more along the way with you guys. But yeah, so what we're going to be doing in this series of videos is we're going to start creating custom distributions so that you guys can learn how to create custom distros, custom machines, add custom features to it, add specific packages, create recipes from scratch, importing recipes, all that good stuff. So I hope you guys enjoy it. Like, I'm sure we're gonna enjoy it a lot just creating it. So yeah, and a quick note, everything is also gonna be documented on our wiki. So we're gonna link everything down below. So if you guys want, you can just go there and follow along at your own pace. But otherwise, please just keep watching the video and hope you guys enjoy. All right, so before we start with the fun part, let's go ahead and define some basic concepts so that we can hit the ground running once we start doing some development. First question we need to ask is, what's Yocto, right? That is a great question to ask if we're going to be doing a deep dive into Yocto. And Yocto is a framework, right? So Yocto is just a set of tools that allow you to create a custom Linux distribution for your systems. So for example, let's say that you are in an embedded device industry and you want to create a system that will have certain sensors, will be using certain module, right? Or certain processor. It's going to be using certain specific carrier board. It's going to require certain features, and it's going to have certain limitations. So Yocto will allow you to tailor make your custom operative system for that specific device, where you get to choose everything from how you configure your machine in regards to what hardware is going to be into it. You get also to choose which specific packages go into your build so that you can optimize for speeds, or you can optimize for space, or you can optimize for everything that you want. Also, Yocto is very cool in the sense that it allows you to very easily reproduce builds. So if you are planning on doing maintenance down the line, which is probably a great idea if you're going to be building a product, so you will be able to replicate those builds across different engineers, across different machines very easily. Now, it also has its cons, right? So one of the cons that's very commonly associated with Yocto is the learning curve. So I'm not gonna lie, learning Yocto at the very beginning might seem a little bit too heavy, right? In the sense that it has quite a steep learning curve. But once you get that slope, you're gonna see it's gonna be super simple. You're gonna love it. It's gonna be a piece of cake just to work on it, and you're gonna enjoy it pretty much. Now, if you guys want us to do a full dive into the differences between choosing, between Yocto and other operating systems that you can use. For example, if you were working with NVIDIA platform, you could choose between Jetpack and Yocto, right? Or if you're working with an MediaTek, with a MediaTek device, then you get to choose between using Ubuntu or using Yocto or using Android, right? So it is very cool. You can choose between these different operating systems. Each of them have their own advantages and disadvantages. So let us know if you want us to do a comparison video or something. You can just let us know down in the comments, and we can definitely do it for you guys. Now, Yocto works in a very interesting way. So you can say that Yocto allows you to define your own distribution as if you were cooking something. So you have these things called recipes. Recipes are essentially procedures that you describe to Yocto so that Yocto can create stuff for you. So for example, let's say that you wanted to add a specific package, I don't know, like GStreamer, and or a custom GStreamer element, and you want to add that to your project. So you will need to create a recipe for that. So the recipe will essentially tell Yocto, hey, these are the ingredients, right? So the source code, you go and grab them from GitHub, or you go and download them from here, from this bucket, or whatever. And then you get to tell Yocto the procedure for preparing that package. So the procedure is essentially just used, I don't know, like if you're compiling a GStreamer element, then surely you're going to be using something like Mason. So you will tell Yocto in the recipe, hey, you need to grab sources from here, then you need to compile them using Mason. So that's how Yocto works essentially, and everything. Like if you want to create your own distro, you're going to have a recipe for your distro. There's obviously different types of files that you're going to be defining. Like for example, you have your .bbs, which are your recipes. Then you have your .bb appends, which is changes to your recipes. And then you will have other like configuration files and stuff. But we can, take that slowly and go step by step once we start building our own distribution. This tutorial we're gonna be doing with specifically and one of these boards that we have here, which is a MediaTek G510. Recently, we've been playing with that board for one of our customers. We've been liking it a lot. It's very cool. But you can follow along with the other different boards if you want. But yeah, for this specific tutorial, we're gonna be using the MediaTek Genio 510. This is a DAF kit. We're gonna be creating the specific meta layer for this. We're gonna be adding features along the way. The idea is to have this be kind of like a large series, so we want to be able to capture from camera, capture from different sensors, use different protocols, show you guys how to deploy AI on it. That's going to be very cool. So yeah, so stick along if you guys want to learn how to do that. And yeah, so let's get started. Before we start, guys, just quick comment. We recommend you guys run this tutorial on a Linux machine. Granted, you can build Yocto on other operating systems, like for example Windows or Mac, but it's gonna be a pain. But I already tried it. You need to use a Docker container. I mean, it works. Like, so at the end of the day, it works. But it's like I tried on my Mac a few times, and it was just such a big pain that I just moved into a Linux machine. I've always been using Linux. Like, I've been using Linux since I started working on embedded, and Linux is cool, guys. So yeah, recommended Linux machine. So before we start, let's assume that you guys have, kind of like a clean sheet in terms of your computer. So we will need to be installing the dependencies. So that's very easy. That's very easy to fix. Just go into developer wiki ProventusNova.com, and then in the main page, if you scroll down a little bit, you will find the create custom Yocto meta layer wiki. In there, you will find in the prerequisites the instructions on how to install the required packages on Ubuntu that you need. So like if it's Ubuntu, you just do sudo apt install and then run this command. However, if you're using a different Linux distro, you can just kind of go ahead and Google that and figure it out. Let us know if you have issues, so it can help you. So we can help you kind of go past them. So I'm gonna go ahead and copy this command. I'm gonna have it install those. I'm gonna have it install the packages. However, since I already have this installed, probably it's going to do nothing. But yeah, so you just run that. It'll say okay, so it seems like everything is there, but there's some upgradable packages, so I'm gonna upgrade them just to make sure that I'm up to date. Then I'm just gonna go to a little repo here. Well, not a repo, a little directory here that I created just kind of to do tutorials into, and we can get started. So first thing we need to do is essentially we can just kind of follow this guy alone, because this guy, like this wiki was written if you wanted to create it was written using a Jetson device. It was just for creating an NVIDIA a meta layer for a Jetson or NX. However, as mentioned, Yocto is pretty cool. It doesn't really matter like what platform you're going to be using. The only thing that's going to change is the layers that you're going to be using. For example, for a NVIDIA board, you will also obviously going to be requiring the meta open for Tegra layer and other kind of like meta Tegra layers that you might need. For in this case, since we're going to be working with the MediaTek board, what you're going to be requiring is the recipes, or not the recipes, the layers that MediaTek puts out. So we're going to go through that in a little bit. So let's go ahead and start with a repo. We will need to create a repo for this. So what we're gonna do is, let me think about this, because I want to do this in such a way. Okay, well, no issue. Right, let's go into GitHub. So github.com. We're gonna name this MetaPNMTK. So it's gonna be named like that just because Meta, ProventusNova, and then MediaTek. Very cool, right? So let's do that. Let's call this. So this is gonna be our I don't know, sample MediaTek demo distro. So MediaTek demo distro by, let's call MediaTek demo distro by ProventusNova. It's gonna be public, no issue. That's code that you guys are gonna be able to access and just clone and build. So that's gonna be cool. And then let's add a readme. Git ignore. We can just don't add anything. Later we can just choose whatever we want to ignore. And license, let's call this non-license or whatever. So we're gonna create that repo. Okay, so we now have a repo, we have main. So let's go ahead and do, okay, let's go ahead and clone this very quickly. So in tutorials, we're gonna do a git clone, and we're gonna do this. I think this might give me issues just because I have, oh no issues. It just worked like a charm. So yeah, ProventusNova, meta p and mtk. Okay, so we now have meta p and mtk. So let's go into there. And now what we're gonna do is we're gonna start by creating our Git history. Like the idea is just not only to show you guys how to do the Yocto, but also you guys can take some tips if you want of how to manage repos. We have a very specific way of managing repos because we make sure that the history is very clean. That allows us to later do maintenance very easily, or to find, you know, where specific features were added or stuff like that. So the idea is we're gonna branch out of main with a develop branch, then we're gonna branch out of develop with feature branches. Whenever we have a feature ready, we just merge those features into develop, and then whenever we have a release ready, we merge develop into main in this case, and then we hit we create a release right there. So let's start by doing that. So we're gonna start by creating the develop branch. Then we're now in develop. So but develop, we're not going to be committing straight to develop, right? That's the thing. So we're going to creating a feature branch called, I don't know, let's do git checkout -p feature, and let's see what our wiki says. So let's go ahead and see what our first step here to create a layer is. So first of all, okay, so we see that we have like we created a meta ProventusNova, in this case directory. This is going to be our meta p and mtk here. There's no reason for you to do other like at the directory name, basically the name inside of the repo directory. You can just do it right there on the root level of your repo. So then we're going to be creating the config file, well, the conf directory, the layer.conf, and then the readme. I'm going to go through which like each of those in a bit. Well, the readme we already have because we created on the git on the git UI. So if you do, for example, ls, you'll see the readme right there. That's cool. So now what we can do is just so we're gonna create a conf named directory. That directory is gonna have all our configurations. For example, we're gonna start by adding the layer configuration, which is the very base layer. The very base configuration file we need to add, but then we can add, like in that same directory, we're gonna add, for example, the machines later on. We're also gonna add the configuration files for the build, for the Yocto build. So yeah, but let's go step by step. Okay, cool. Let's do the layer.conf file. So what I'm gonna be doing for this is I'm gonna do just code. I don't know what IDE you guys use, but code is pretty cool. So what we're gonna be doing is we're gonna be copying this configuration file right here from our wiki. So that's already, oops, thought I was on the Mac, so no command key here. So okay, cool. Now all right, so conf, we're gonna create a new file called layer.conf, and this is gonna be the configuration file for our own meta layer, right? So Yocto is like an onion, or a Yocto builds like an onion, and you have different layers. So essentially you start with a very base layer, which is like, usually the very base layer is just Yocto layer, right? Like bulky and all that. But then on top of that, you start adding layers. Like for example, if you're gonna be working with a MediaTek board, then the next layer you're gonna add is the MediaTek layer, so that you can have support for the hardware that MediaTek provides, right? Then let's say that you're gonna use a frame sensor. So if you're gonna use a frameless camera sensor, probably you will need some sort of layer for that. Then let's say that you wanna use, I don't know, like whatever you wanna use. Like in this case, for example, we're gonna be creating this custom layer. So if someone wants to replicate our project, they need to use our layer for it. So that's cool, right? It's like an onion. So we're going to be working on a layer, and this layer configuration file will allow you to specify different stuff like whenever Yocto is going to be building your layer. So this configuration file will tell Yocto like how your layer is configured, and we're going to go step by step here on what these things mean. But it's very simple. Like for example, here the BB path variable, environment variable, just defines what the layer where the layer stores the recipes. So in this case, it just kind of uses this other environment variable, which is layer dir. Then we have the BB files. Essentially, this doesn't change for any layer that you're going to be creating. It just tells Yocto, hey, look here for the recipe files that we have in this layer, right? So essentially, it's just that. It's telling Yocto where to look for when Yocto tries to find BB files, which are the recipes, which we already discussed earlier in the video. You know, recipes are the way you define or tell Yocto how to add support for different packages. And that's what a layer does, essentially. And then what's next here is the BB collections. So these other variables here, what they do is just they define kind of like names and stuff that Yocto is going to be using. This is also not very important. So in our case, what we're going to be doing here is, since our meta layer is no longer called meta ProventusNova, we're going to change that to whatever our layer name is. So in our case, the layer is called meta pnmtk, right? So what we're going to be doing is we're going to be creating we're going to call this pn-mtk. Okay, so for and actually let's do kind of like a quick swap of everything. So everything that's called ProventusNova now takes the name of our layer. Our layer is named pnmtk, so we're going to name it like that. So pn-mtk, which remember that stands for ProventusNova MediaTek. Then this priority here is very important. This is something you might actually need to play with later on. And what this tells Yocto is like what's the priority of this layer when compared to the other layers. And the lower number, the lower priority it has, the higher number, the higher priority it has. And what this does is, like for example, let's say that you're using another layer. Like let's say that you have that you're using a layer that, I don't know, adds support for a certain GStreamer feature, and then you'll want to have your layer add that same support, but then you have a different recipe for it, right? Like let's say that you add changes on top of it. So essentially, as long as your priority, as long as the priority on your layer is higher than the other layer's priority, your layer's changes will come on top. If not, then the layer's changes will come on top of your changes. So that is important to understand, right? So the thing that we need to make sure we understand here is like whatever, like the priority determines what changes are gonna go on top of what other changes. So if two different layers add, or two layers or more have the same changes on a recipe, or have changes on a recipe, essentially the one that with the highest priority is going to come on top. So that's how, like, all of them are going to apply. Don't get me wrong. Like if you have you know, BB append after BB append after BB append, then whenever there's conflicts, that's where one will rule over the other. But if there are no conflicts, like all the BB appends are going to apply very easily. But this essentially will tell Yocto, hey, like in this case, we're using a pretty high priority here. Like this was taken from MetaTegra. MetaTegra does that. MetaTegra has a very high priority just because there's a bunch of different layers coming into it, and they wanted MetaTegra to be kind of the highest one. In our case, we wanted also to be the highest one, so we added the same priority. But this we can change. Like for example, if we're going to be doing for MTK, we can lower this to whatever makes sense to use. In this case, we're just going to leave it to 50. That's going to ensure that our layer comes on top every time. Then the layer version, this is just a kind of like a versioning thing we need to use. This is very important too. The layer series compat, this determines what's going to be like with, like Yocto has different versions, right? So for example, you might have a Scarlet Gap right here, which is I think one of the latest ones. Then you have Kirkstone, then you have, I don't know, like they go all the way to the very beginning where, you know, you had Sumo and other versions. So essentially this tells Yocto what Yocto versions is this layer compatible with, right? So if you want this layer to be compatible with only ScarfGap, then you do ScarfGap. But then if you want this to be compatible with other like Sumo or Warrior or whatever, then you just need to add here. For example, if you wanted this to be compatible with Kirsten, you will come here and write Kirsten, right? But right now we're gonna be just using ScarfGap. Or well, I don't quite remember because we'll need to look into what the MediaTek layer supports. I think it was Kirsten based, so we'll need to look into that. We might want to change this to Kirsten, but let's just leave it like that for the moment, and then we can start working on it later. This is used by the so this is used by the Tegra Distro sanity checker. So since this is all Meta Tegra stuff, we don't need it. We're working with MediaTek boards here, so let's just remove that. Okay. So essentially, this is how our layer is coming. This is going to be configured for now. We can just go ahead and double check with the MediaTek. So it's called GitLab MediaTek AIoT. What I just to confirm is what version of Yocto we're gonna be using, so that we can use the same. And let's go look for it. So their main like for MediaTek, their main like they have a bunch of meta layers here on the repo, obviously. So, but their main kind of like meta layer for their images is called MetaReady. I don't really know what where the ready comes from, but let me see if I can find that over here. So if you can see, like, this is a meta kind of like a repo called MetaReady. Inside of it, we have even more meta layers, but we're gonna go into the MetaReady demo. That's the one that they ask kind of like people to use whenever they're following, whenever you're following kind of like their whenever you're following their tutorials. So let's go ahead and look into the MetaReady demo, the conf directory. Now you guys know that the conf directory will hold the configurations for the layer at least, and any other stuff that they want to configure at a distro level. So in here you will see they have the ready demo conf, right? We could even base off of this if we wanted. Like we could change our completely configure, or we could change our layer configuration to match this one, which makes even more sense than just using the one that we had here, which is a little bit more simplistic. But yeah, we can even do that. Like if you guys want, we can go ahead and just come here, and I'm gonna take the raw file. I'm just gonna replace all this that we just did. And if you guys see, it actually has the same things. So BB path, it's around here. So let me see if I can see that. Wow, I don't actually see it here. Oh, that's interesting. So maybe they're just using the default, because there's obviously a default BB path defined for this. So what we're gonna be doing is, so let's just use this. Okay, so there you go. So what they are doing here is they require this ready.inc from conf distro. So, and on top of that, they're just adding a bunch of different stuff. So we can just go ahead and take a look at what what the ready include has to offer, and then we can decide whether we wanna. Okay, so let me see. So conf distro ready.inc conf. Okay, no, I know. Okay, cool. So that was the reason why it was different. Cool. Now I look like a dumb. Like I don't know. So yeah, so let's go ahead and compare this to this, for example. Now we were comparing different things. We'll go into what I was just copying wrongly here. It was just the distro configuration file, so it is different from the layer configuration file. That's why it was so different. So now let's compare these two. So we have the, like, from this line to here is MediaTek. This is the one that we grabbed from our wiki. It's more NVIDIA-like. So you will see that we have the VB path, like that's on every layer configuration file, the VB files, then the VB dynamics. These ones, you can see that they are for software update. So we can either remove that for now, because like, for example, the recipe file here from MediaTek doesn't have them. And that is mostly because this software update stuff is for OTA updates. And we can just remove that for the time being, and we can just add that later, or we can just leave it there. Like it's not gonna do much. So let's just remove it so that it kind of like stays sane with what the MediaTek have there. And then, okay, so they have the BB path, they have the BB files. Then they have the collections, and they have their patterns, right? Then we have their priority. So you see the priority is 9, so we can lower our priority to 9 if we want. Then here's what we actually came for, which is, okay, let me see. So they have this should be only incremented significant changes, so it calls okay. So this is for the layer version, so let's just leave it there. And then they have the layer depends ready demo. So this layer essentially depends on all these other layers like core, MediaTek BSP, MediaTek TSN, BlueDroid, demo, layer. So this just essentially tells Yocto, hey, if you wanted to build this layer, then you will need to comply with this with all these dependencies, right? And then this is what we actually came for, which is very funny. So we actually came for it just looking for this specific value. We wanted to know if we were going to be able to use Scarlet Graph, for example, for our compat. But as you can see here, MediaTek is currently using Kirkston. And one thing that we can do is actually, because I recall that they synced their branch to a specific, well, they sync their build to a specific branch, which is this one, refs. So I'm gonna go ahead and sync it to this one just to make sure that we are using what they suggest using for building the Yocto layer. So I'm gonna go ahead and come here because this is Kirkston. So I'm just gonna go ahead and look for this. Oops, let me see why it's not. Okay, so this is a tag. It's not a branch. So I'm gonna go ahead and come here. Let me see if I can find the tag. So tag is ready Scarlet Cap. So I'm gonna just do this. There you go. So this is the tag, ready Scarlet Cap bit 25.0. This is the config file. Once more, we're gonna go ahead and copy that. I'm just gonna replace the whole thing now that I have explained what that is. So yeah, so just replace the whole thing. We're gonna be basing off of this specific layer configuration file. We started with the one that we had on the wiki, and however now we're just gonna be using whatever MediaTek suggests we use, right? So they suggest using this one, right, based on their wikis. So we're gonna be using this one as we saw. We still have the BB path, the BB files, the BB everything. So we're gonna be changing this ready demo for what our meta layer is called. If you guys recall, we called it PN-MTK. So we're just gonna kind of like do this, and do this, and then we're gonna replace all read demo appearances with PN-MTK. So PN-MTK, that's our layer name, and this we're not gonna change because as they suggest here, it's better not to change it. And then they have this fix me remove layers, and then okay, I don't know, this is an interesting comment. Yeah, we're just gonna leave it like that for the time being. These are all the layers they can require, and as you can see, actually this is very interesting. So see, since we changed to this new version, release card cap, now on the tag on the Git repo, now we see that actually they added support for Scarlet Cap, which is the newer version of Yocto, which is cool because it is better to use kind of whatever is newer on Yocto, however newer but stable, right? Because Yocto also has that thing, which is, since it is maintained by the community, what could happen is like people are just kind of pushing changes constantly. So if you're not using something that's stable, it might break your build. That's something that we're gonna try to fix later. There's couple ways we can do that. Like for example, we could use either a manifest just to keep track of kind of, so we can sync our build to specific commits on every single meta layer, or we can use something like, for example, Git submodules, which is also very useful. But yeah, so for the time being, we're just gonna be using this. Okay, cool. Now we have our layer.conf file. I just noticed that I have a typo here, so I'm just kind of rename it. So rename layer.conf instead of .con, and that should fix it. So yeah, let's go check our wiki because we are already done with our first step. So yeah, in here we already did that. So we're gonna just commit this just to keep it clean. So our first commit is add base layer.conf file. So we're gonna, oops, no, not Mac once again. That's cool. Okay, but yeah, so I'm gonna just create this commit really quickly. It's gonna keep it clean. So we're gonna give git status. You will see that we will have this conf file that is not tracked. So we're going to be doing git add conf layer.conf git status once again, just to make sure. So we have a file right there. We're going to do git commit -m. Then we're going to add this commit message, which makes a lot of sense. Actually, the wiki is hard done in such a way that you can just kind of use the steps as commit messages, and that's going to keep a very clean git history. So git commit. Okay, we're going to do this real quick. All right, we have a commit. Git log. There you go. Cool, right? So now let's see what we need to do next. So we can do a tree if you guys want, so you can see that we are kind of compliant with this structure. So if you do tree dot, then you'll see that we have the meta. Well, we're outside the. We can do 3 dot dot, I think, and that should work. Yeah. So we have the meta pn mtk, which is this meta ProventusNova. Then we have the conf directory. Inside we have the layer conf and then the readme. So we are all good to go. We're right within what we need to do in order to get this right done. So now we're gonna do the base distro config. So this is what you know, a while back I was trying to get the meta ready demo layer conf, and I actually accidentally copied the distro config, and I was kind of like taken out of base just because it was so weird and didn't have some stuff. So well, you know, long story short, this is the file that we want now. Okay, cool. So let's go ahead and create a distro directory inside the conf directory, and then we're gonna create the distro conf. So if you guys come here to the MediaTek repo, you can actually see that exact same structure. That is because just Yocto structure, so every Yocto is built the same. In here, you will see like we're inside the conf directory. Inside of the conf directory, we have a distro directory, which is something that we need to create. So let's see, we have right now we have only conf directory, so we're gonna mtk dir. So mkdirs, make dir conf distro. There you go. So we can do 3. Now we have the distro directory inside the conf directory, and now we need to create the configuration file. If you guys pay some attention, you will see that the configuration file for this distro uses the same name that the meta layer has, right? So this meta layer is called meta ready demo, and then the distro configuration file is ready demo conf, right? So the meta doesn't go into the name of the file, but then the rest of the name, which is the actual name of the meta layer, goes right into is used for your file. So taking that into account, what we'll need to do is just come here, open our distro directory. We're gonna create a new file, and we're gonna name it how pnmtk.conf, right? So pn-mtk, which is the name of our meta layer, and then conf. So if we go here, essentially this is we want a base of this configuration file, which is MediaTek1, and then you see that's named the same as our meta layer. That's how it should go, right? So we're gonna copy this, and then we're gonna paste it here. So you will see, guys, that this first of all, you will notice this require. This is because we can require files that are even on other meta layers. As long as you have the meta layers installed in your Yocto build, which we will show later how to, you will be able to pull these config files or whatever. Like essentially, you can just kind of like inherit other stuffs like classes even. But in this case, it is an include file that is from conf distro ready. And this is one thing that we can do. Like, for example, we can just leave it like this, since we're gonna still add the ready meta layer later. Like in theory, we should be able to pull that. But if you guys want, just count for curiosity, we can just go here and try to find that include file, because I was trying to look for it earlier and I wasn't able to find it. So I guess it's not on the meta ready demo meta layer. It's probably somewhere else. So if we go one step outside, we will see what we're playing with this meta ready demo. So I guess it's gonna be either on skeleton or on bring up. So let's go to skeleton. That makes more sense. Then conf, then distro. So we have the distro skeleton conf. Let's see if this includes the same thing. Yeah, they include conf distro ready inc. Let me see if this is somewhere else around here. So local machines, machines, where the machines go, so it shouldn't be there. And then we have meta ready. Let me see, meta ready cast docs, meta ready bring up, conf. distro really bring up conf, so it's not that either. That's very interesting. Where is that? So meta conf distro ready inc. So this is the file that all those other meta layers is trying to import, right? So for example, this one we just copied over from the MediaTek demo distro config file. So this required conf distro ready is right here. So right, and actually it kind of requires a different one. It requires the Pocky one, and Pocky is just from base Yocto, so we don't need to worry about that. Like we're gonna require Pocky regardless. So what I want to actually see is like what what are we including here? So does it make sense for us to include it or not? Like just that, right? So just to make sure, we're just gonna look into here. So it called like it has a very basic distro name, this like a distro, a basic distro name, a basic distro version. It has some Python functions here. These Python functions, let us see what it does. So it says that sets WKS file according to the features. So that's very interesting. Really, I don't really understand what that is. We'll need to look into what that WKS file is, so we can look into that later. Okay, defines a very basic image home size. We can probably change that later depending on what we need. And then it has the current classes, UBOT suffix, blah blah blah. So yeah, we can just leave that there. I don't think it's gonna do any damage. Then we have, like for example, here what you can see is this is very interesting actually. So in here you see the distro, it's changed. Like we import like in this file, this is now our file. I know that we copied from MediaTek, right? But it's now our file. So what we're doing here is in line 3, we're changing, even though we are importing ready inc, which already defines distro to ready, we're renaming it, right? We rename it to the name of our distro. So let's do that. Let's go ahead and rename this to pn-mtk, which is our distro. Then they provide a name, so they would say this is ready demo layer. So what we're gonna do is we're gonna create we're gonna do pn-mtk demo layer, right? So we're gonna do that pn-mtk layer. So I'm just gonna leave it like that, pn-mtk layer init manager. So this is already selecting which init manager we're going to be using. Systemd is very cool. Let's use that. That's widely used. You know, if you want to demonize stuff, you want it to be done with systemd in this case. If you wanted to use another init manager, you can definitely do it. You can look for it and use it. However, in all the years I have kind of like working on this, systemd is the way to go. Then okay, distro features. There are some very basic distro features that are already included in the demo and in this demo distro, which are, for example, PyWire. This is a demo one, probably is a package they have. PAM, firmware update, expand with FS, and BTF. Okay, we can just leave them there. Then it seems like they're using Wayland, and then they're also adding Vim as the virtual runtime environment. Let me see what else they're doing here. So mount var log in present storage, so it's possible to keep journal logs. Okay, so this is for journal logging. That's cool. We want that, right? If one of our services is not working, we can just go ahead and look into there. Then they have the config file, pn western init, no idle timeout, package classes, package deb. So yeah, we want that, and then package fit URIs. Okay, package management. Okay, this all here seems to be very basic stuff, so it doesn't really bother me just skipping it. One thing that we can do is, like for example, if like we saw we already had other meta layers, like we are currently basing ourselves like our meta layer or out of MetaReady demo, but we can definitely check MetaReady skeleton, which sounds to be a little bit more streamlined. So if we go into a distro and we check the distro configuration file, well, yeah, this is a lot more streamlined in the sense that it is empty. Like we don't have, like, besides the naming, I don't think there's pretty much anything left. So they're importing that, they're just defining the naming, and they're just leaving everything as really requires it. However, I'm really liking how the demo stuff is defined here, like systemd and all that. So let's just leave it like that. I'm sure it's gonna be working perfectly, and we don't probably we're not gonna be coming back to this in a good while until we are ready to add new distro features. So cool. Now we have our distro configuration file. So let's just go ahead and check. So that's, if we compare with our handy dandy guy here, you will see that we have step 2 add base distro image. It has this specific structure. So if we go ahead and do a tree, now we are matching that tree structure. So we have the conf, the distro, and then the PM MTK conf, which is how everything is here, which is very cool. So we were already checking the, okay, so we already created the distro. We checked it matches what we have on our wiki, which is great. Now we're ready with that. So what we can do is just remember, we can just go ahead and copy here the config, this add base distro config thingy. This works perfectly for the git commit message. So we're gonna come here, we're gonna get status probably. Okay, yeah, so this is stuff that's not being tracked by git, obviously. So what we're gonna do is git add conf distro and the conf and the distro config file git status once again. So that looks pretty good. Let's do git commit dash m, the name of the commit message, which is gonna be add base distro config. Pretty cool, right? And then we're gonna hit enter. That's gonna require us to sign the commit. All right, so we're good to go. Step 2 done. Easy. So far, so good. Let's go ahead and check into step 3. So add base machine. This is where it starts to get more interesting. So machine files. This is very cool. So let's go ahead and look into what we need to do. So we'll need to create a machine directory inside our configuration directory. So let's go ahead and do that. We can do that either here from, we can even do it from here from code. So let's go ahead and create a new folder. Let's name it machine. That's cool. And then let's see what else do we need to do. So we're gonna be creating a machine file. What are machine files, you might ask yourself? Amazing question. Very smart. So machine files are actually files that will define how your device is configured, right? So for example, if you needed to add a custom device tree file for your system, it will go into your machine configuration. If it needs specific configuration parameters, I don't know, like whatever, like if you need to add a firmware configuration parameter or a bootloader configuration parameter, well, whatever that's related to your actual hardware goes into machine. And it is always a great idea to create a machine configuration file, even though you're going to be using someone else's as a base. Like for example, if you were going to be doing a machine based on NVIDIA Jetson, MediaTek already provides a bunch of different machine files, so you can base yours off of them. But what's important here is, like, if you create your own machine file, then you can inherit whatever you want to base off, just as we inherited before, like as we were checking the inheritance of really Inc. But in this case, you will inherit the machine configuration file, and then on top you can add your changes. That's a lot more clean than then just trying to do the changes on top of whatever recipe you want to do. And that's not good. So let's create our own custom machine file. Let's go ahead and see what MediaTek has on the repos. That's always smart. So let's go ahead and see here. So in the MetaRead skeleton, they have a machine. Let me see if they have a machine also here on the MetaRead demo, but I don't recall so I don't think they have. So no. So for the demo, they only have the distro, but machines are defined on the skeleton. So I assume they usually use just the machines on the skeleton. So let's say what they have here. So okay, MetaRead skeleton, config, the conf directory, then machine. We already have that, and then they have the i500 skeleton.conf. Let's see what this is. So essentially, they're just including the MT A1A3, which is the 510, I think, and then they're adding custom DTV, just as I mentioned. So if you wanted to customize DTV, just add it there. And it seems like this is for the pumpkin. So MediaTek produces the sum or the chip, like the system on chip, right? The SoC, but the carrier board, like those are usually not produced by MediaTek. Okay, yeah, granted, MediaTek has their own dev kit, right? That is produced by someone else, and there's also a bunch of other partners from MediaTek that produce amazing dev kits. Like for example, you have this pumpkin dev kit. We can actually look for it. So it's G510 pumpkin. Let's see if we can find it here. So G510 pumpkin, that's done by Logic. That's the name of the company, and they have this. Actually, it's a very accessible priced dev kit when compared to the other ones, and it's very cool. So yeah, so that's that. So that configuration file seems to be done for that specific machine. Let's see if we can find another machine that makes more sense for us to use. We will need probably to go look for it somewhere else. Let me just see if we can find it here. So machine include. Okay, yeah, this is for the pumpkin still. We don't need that. So let me see if we can go into Ready. And let's see if we can find some other meta layer that might offer us a proper machine file that we can start from, right? So let's see if like this makes sense. MediaTek BSP. So BSP board support package. That's always related with, machines and hardware and all that. So very cool. So let's go here. So yeah, they have a machine directory, and yes, they have a bunch of different machines. So we might need to get ours from here, which is very cool. We already found them. Let's see what we have here, and then we can decide. So let's see. We can maybe try to Control F. Well, already found one here. So this is called Genio 510 EVK. It seems to be a kind of like it seemed like a link to another file. So this Genio 510 EVK conf, the EVK stands for evaluation kit, so that works perfectly with what we have here. And what they are doing is essentially just linking MTK this file here, so MTK A370 EVK. So let's look for that. I'm gonna just Control F it because I'm lazy. So here it is. So you can see it's like they're including the same file that the pumpkin configuration file was including, plus one other thingy here, the 7921, which I don't quite remember which what was that. So we can go look into it in a little bit, but I assume we can just base off of this file. So let's just kind of go through it very quickly. Let's copy it over. I'm sure we can use this. So let's create our own config, like our own configuration file. Let's call this I don't know, like G510, like let's call MTK G510.conf, right? Yeah, .conf. So MTK G510.conf is going to be the name of our configuration file for the machine. So whenever we want to build for this specific machine, we can just do MTK G510, or if we want to create another one for, I don't know, like this 700, we can just add it here, or the 520, which is coming very soon. So yeah, so let's just copy over here this file that we're going to be basing off, and then let's look into it. So they define the device tree. Since we're going to be using the EVK and there's not going to be any changes done to the device tree because we're just going to be using the same carrier board that we have, let's just leave it like that. Then they have the UV configuration. Also, I would just recommend, like, if you don't have any specific changes done so far to your board, like just leave it like that. It's gonna work with the EVK. I'm sure this is just gonna work out of the gate. So libdram, it is very interesting. So they use a 700 EVK file for the libdram board name, but we can just leave it like that. I don't think that's gonna affect. If it works for them, it will work for us. Then the opti DRAM size, LK board name. So in here they have the Genio 510 EVK. Makes sense. And then they have machine features, so they add some machine features. Now, I don't know if you guys remember, but when we did the distro file, which actually we have here, we don't need to recall, right? So when we did this file, we have distro features. So distro features were packages that we added specifically for the distribution. In here, we have machine features, which are packages that you add specifically for a machine. What's the difference? The difference is like for example, you can use another distro with your machine, or you can use, right? So whatever changes are associated with the machine, wherever you use that machine, those changes are gonna go to, right? And the same goes for the distro. Whenever you use your distro, those changes are gonna be, as long as you use the distro, those changes that are associated with your distro are gonna go into whatever you're building. So just take that in mind. So these packages here make sense to be on the machine because the machine supports audio, the machine supports Bluetooth, the machine supports PCI, USB gadgets, USB host, Wi-Fi, TSN, and UC FDE. If you're building another machine that doesn't support Bluetooth, like, why would you add that package, right? So that's kind of the logic that we need to follow here. And then we have these machine overrides. Essentially, this just tells Yocto, hey, if this machine is a good override for like this machine can be an override for this. Like if you use this name, use this machine file. If you use this other name, use this machine file. Okay, so that's it. And then there's some on-semi firmware that seems to be for some cameras, like the AR 0430 and the AR 0830. We can look into that later. but it doesn't make any damage to leave it here. I think that's because the cameras that are included with the dev kit, which we're going to be enabling later, they come they're on semi chips, so we'll have to kind of don't take that with a grain of salt. I'm not really sure, but we'll kind of verify that later once we enable camera capture. But this seems pretty good. Like, this seems pretty sane. We can just use this configuration file for our machine file. All right, so let's do the same. So let's go into our wiki. Let's just copy this step and let's use it as our commit message. So same thing. I'm sure you guys already pretty familiar with Git. So Git status. Okay, there you go. Git add conf machine file, git commit -m. Then we're gonna add that right there, and then we're gonna do. Okay, so we didn't need to add use the password because we already did it very recently. So cool. Okay, now we have our machine ready. We're getting very close to start building our Yocto. So initial config file templates. Okay, so we have already done. Let's do kind of like a quick recap. Okay, I know you guys want to start building now, but okay, let's take our time. So let's do a quick recap. So far we did our layer configuration file. So we told Yocto what our layer looks like, what does it do, how does it behave, right? Then we added a distro conf. So we started defining our distro. We added a base distro config file. Later, if we want to add features to our distro, we can do it there. We also added a custom machine, which now allows us to define custom changes for specifics of our device. So if we wanted to add another sensor, you can definitely add it there. Okay, cool, right? Now, what's next? I don't know if you guys recall, but at the very beginning of the video, I discussed that besides those config files, there are also other configuration files for the build. And these are these config template files. So whenever, like, you already have defined how your layer and kind of like all the ecosystem in terms of software you added behaves. But now you need to tell Yocto how to build it and where to find stuff and what to make use of, like, right? So that's what we're going to be doing here in a bit. We're going to be creating template files. There are two files that Yocto uses in order to determine how the build is going to happen, right? So if you're going to be defining that, like, and those two files are named bb_layers_conf and local_conf. So bb_layers_conf is a file we're gonna, like, if you guys see here on the wiki. So this file bb_layer_conf essentially just tells Yocto which bb layers to use. So bb layers are just Yocto layers, Yocto meta layers. So it is not enough with just kind of like cloning the meta layers into your local system. So Yocto is not gonna be, a magical thing that is gonna go and look for the files or look for what layers you have available. You actually need to tell Yocto what layers you have available for this build, and this is where you do so. So it's very simple. This, like, the structure of this file is super simple. It's just telling Yocto where to look for the layers that you have. Okay, cool. Now the other config file is the local conf file, and this essentially is just a local configuration file that will define some environment variables that Yocto will use to build your system. Let's use this example. In here, we are defining the machine. So let's say, like in this case, we're building for ProventusNova Jetson X 16 dev kit machine. Then we're also defining the download here. This is where Yocto is going to download all the resources. This is very important to define because, like, Yocto is going to be downloading a bunch of stuff. All the source files for Linux, all the source files for any package that you want to install, it's going to download. And as long as you download them into a specific file that you're not going to change later, Yocto keep tracks of that. So whenever you're rebuilding your image, like the first time it might take a bunch of time. Like the first time you build Yocto, it might take hours. But then after you build, Yocto already knows it has already downloaded all the files. So it just kind of goes and looks there. And the same goes for the state cache file. So the same thing is Yocto keeps track of everything, so it has a cache, and then it will go look into that cache for understanding what's the current status of different packages you already built. So that's very important to have defined so that you can make sure that you're not kind of doing this over and over again every time you build. So important to have there. And then it defines a temp there. That's where it's going to build everything into. Then it defines the distro that we're going to be using. So if we have multiple distros, with different features, for example, you can choose that here. And then, a bunch of other stuff like package classes, subnet, SDK machine. There's a bunch of different stuff that we can define here. And everything changes depending on what you know, on what kind of like metal layers you're gonna be using, and what the machine, like what the system you're gonna be using is. Like depending on everything, you might have even, you know, different environment variables to define depending on, you know, what layers you have, and so on. So let's go ahead and do the same the same thing. We're gonna go into the MediaTek repo. This is gonna be kind of our the like we're gonna be basing off. So let's go here and look for some template files that we just can copy over and modify them so that they accommodate to our custom build. So let's go here. I'm sure. Okay, so yeah, in the BSP they have config files. So they have the bb layer conf sample and the local conf sample. So we can just see that and see if that's gonna work for us. Okay, one thing that we need to take into consideration here is that we are on Kirkston, so we might need to go ahead and redo the machine. Let me just do that very quickly. So let's go into machine. Let's do the actual branch that we want to use, which is really scarf gap B25. So this is where this is kind of like the this is the tag that MediaTek suggests everyone syncing to, right? So let's go ahead here and look for, let's yet again just look for G510 VK. Kind of refers to this file. I'm just gonna make sure that we have the proper things instead of something that's outdated. So I'm just gonna copy this and I'm gonna copy it here. So I'm gonna just replace all that. So yeah, it seems like something changed. They added driver for external I2C device. So that's cool. Let's go ahead and fix that on the Git real quick. And they also changed this, it seems like. Check G510 EVK GVT. So device tree changed. And they also changed, you know, this, they added support for the external I2C device. So that's very important. Let's go ahead and add that. So we're gonna do git status and git diff just to make sure that the diff looks good. Yeah, cool. So git add -u and then git commit amend, because I don't want to redo the same kind of like a tiny commit just for that little mistake. So commit amend, then we're gonna close that. Okay, cool. Now we're up to date with that. Cool. Now let's go ahead and look into, okay, what we were doing. I already forgot. Yeah, we were doing the conf. This is card gap. Okay, so it seems like the I don't know if you guys recall, but we were trying to see the templates here on the MediaTek VSP, but seems they've removed them from here. So let's go ahead and let's go look for them. I'm sure they are on the demo repo. So we'll need to, okay, yeah, we'll need to go to ready. We'll need to go to meta ready. That's where the meta demo is, right? So let's see meta ready demo. Let's go ahead and sync once again, because every time we switch from repos, this is reset. So I'm gonna go ahead and look for the proper branch. We're gonna go into conf. Okay, we didn't have that here. Let me try to find that for you guys real quick. Recipe support, recipes demo. Okay, let me see where else. So maybe in meta conf. Yeah, templates default, templates include. Okay, templates default. We have them here. So templates default. I think these are the ones that they're using. We can just verify that very quickly by coming here and see what the commands they're used for this are. Okay, so they're using this is the templates. We're gonna go through these steps in a bit whenever we start building. But for now, let's just go ahead and see what they're doing here. So what they're doing is they're doing template conf project root. Then they're looking for meta ready meta conf, and that's exactly where we are right now. So we are in meta ready meta conf, and they're using these templates right here. Templates default. So we can just replicate that really quickly. So we can just go ahead and do view layers conf sample. So let's do. Okay, let's create the templates directory here in this in conf, right? I'm gonna go ahead and here in conf, I'm gonna just go ahead and create a new folder. I'm gonna call it templates. And then instead of the templates directory, we're gonna call one default. Okay, We can change that later, like, and have different templates for different layers. So we're gonna do templates default, and then we're gonna just come here and copy this BB layers config file. So I'm gonna go ahead and do new file. I'm gonna call it BB layers conf.sample. So I'm gonna copy this because I'm too dumb to remember that. It's a new file. Boom. Okay, there you go. Cool. Now we can use this right here. This we might need to change later because depending on what strategy we use and where we're gonna be putting the meta layers, we're gonna require to change this, right? But for now, this works. Okay, cool. And we might want to remove a bunch of meta recipes from here, like meta layers from here, because they might not make sense, but we will see. Okay, and then let's do the local conf file. So we're gonna come here, do the full new file, local.conf.sample, I think. Local conf sample, yeah, there you go. So this is the local conf sample. This is layers. Oh, sorry, this is the BB layers conf sample. And then let's look into the local one because there's a bunch of comments that we might want to remove. So here, for example, we're gonna remove this. This is all kind of, explaining how everything works. We already understand that. So let's go ahead and change this for our machine. Do you guys recall? We have now a machine, so we need to add ours here. So MediaTek G510 conf. So we're gonna name this, or we're gonna change this for, and well, we're gonna do is this. We're gonna just remove this machines here. We're gonna change this for our machine. So MediaTek G510 and the conf you don't need to add. Where to place the downloads. So this is allowed the downloads directory. What we're gonna do is just leave it there, top tier downloads. That means like whatever you run the BigBay command on the top tier, use that, right? Cool. Where to place the share files, the same thing. Where to place the build output, so the temp, we're gonna do that. That works too. So let me see. So download here, downloads. Let me see what they do here, because I recall they might just kind of change it for them. So they export build here, pwd. Okay. Okay, yeah. So let's change this so that it's like that, right? So we do want to use top tier state cache, top tier downloads, and we also want to use top tier temp. I think that's how we define it here also. Let me double check that real quick. So we go here into the and the down, yeah. Oh, okay, yeah. So we're doing top tier downloads. So top tier downloads. We'll need to see what top tier is actually there, because I don't quite recall. But we can definitely leave it there for the time being. So we can do okay, cool. Yeah, for the time being, just leave it like that. And then default policy config, they use ready demo. But what we're gonna be doing is changing that, because the policy config that we're gonna be using is bnmtk. Okay, we're gonna remove this. And then package manager and configuration. So this is like you can configure Yocto. Yocto is so cool. You can configure it to choose which package manager you want to use. In this case, by default, it's IPK. IPK is recommended for embedded devices. It's kind of like a more streamlined package manager, but you can even add multiple. Like for example, you can even add Debian package management. So you have Yocto not only building the IPK packages, but also building Debian packages, which is very useful also. Like if you wanted to have custom Debian packages be created for, from your build, so that you can later install on user space, you can definitely do that too. So yeah, just kind of take that for what it means and do whatever you want with that information. But yeah, you can change package manager if you want to use other stuff. The soup machine, this is for the x86, but we're just gonna remove. Okay, so we can just leave it like that. And then S-tray much configuration defaults. So these debug tweaks, is for enabling you to access, to log in into a board without you having to use a user and a password. These are other kind of like extra features you can add, but you just kind of leave it like that. Just gonna clean it out a little bit. Then additional image features. Okay, so build stats, that's cool. Runtime testing of images. This is if you were gonna be using a kind of like an emulator for testing. Like for example, this is for QEMU. But we're not gonna be using that. That's why it's commented. We're just gonna leave it there if someone else wants it. Depending, like if I were building this for a customer, I would remove everything that's commented, because if it's commented, it's not used, and if it's not used, it's not required. If not required, it's just kind of like taking space there. But since this is going to be used by you guys on different projects, you might actually need it, so I'm just going to leave it there. But take that for what it means. Like if you want to do your own project and kind of keep it clean and tidy, I would suggest removing whatever is commented, because not used. If it is not required, better not take space. Okay. Yeah, so that's it. Then we're gonna see this. I'm gonna remove this. Okay. Disk space monitoring. So yeah, that's cool. I'm gonna change this here. So remove that. And then yeah, same here. And then same here. This is the mirrors, right? Like whatever you want Yocto to go and pull stuff from. So you can modify to this QEMU configuration. Gonna leave it there, comment it out, just as I mentioned. It might work for some of you guys. And then this is the sanity check, hash equivalence. Once again, like if this is not used, you might just want to remove it. And then memory resistant bit bake. Let's see, what does this say? So the components stay in memory after UI. Okay, yeah. So you can just leave that commented, like not needed. Conversion is increased. So this better not to play with unless you kind of want to mess stuff up. This is gonna go ahead and match with the rest of Yocto. And if it doesn't match at some point, it's just gonna break and it's not gonna build. So just leave it like that unless you really have a reason why to change it. Okay, licenses. I'm gonna just leave it as commercial, but you can change that. Like in this case, it's commercial, but then you can just maybe, I don't know, you just want to use MIT licenses on your project. So if you change that here, then later whenever you're building, Yocto is going to go ahead and check against this all your packages. So if some of your packages are not kind of like within this specific commercial license, for example, requirement, then Yocto is going to let you know. It's going to kind of break, right? It's going to explode in your face, and it's going to tell you, hey man, you're trying to use a a package that doesn't match the license requirements that you have in your configuration file. So we're not going to continue from here. You need to decide whether you need to whether you want to allow that license or whether you need to change the package. Okay, cool. Now, this is to connect to a board by default. Okay, this is the host name. You can leave it like that, or later change it if you want. Image of types, so tar. Okay, you can change that here. This is like how you want to package your images. Okay, this is kind of like the default, but you can change this if you want more space. For now, we just leave it like this, and later we can kind of like enable more space. Like for example, the dev kit actually has a bunch more space than this, so you can enable that if you want. Yeah, I think it's 64 gig. I need to check, but I think it's 64 gig, and this is just kind of like 2 gigs, I think, or something like that. So it's not great. Or 20 gigs. I don't know. I forgot, but we'll need to check. Uncommon to enable multi-lib support. Okay, blah blah blah. Device tree overlays. Okay, this is cool. This is the device tree overlays. So if you want to enable stuff, you can come here and add the overlays, right? So, for example, if you had a camera, right, overlay, you can come here and enable it. If you can see here, we have for the Genio 350, 700, and 1200, but since we're using just the 510, we're gonna remove those and just leave the overlays that we want for our platform. So we're gonna be using the video, the TVO, the APU sys, the TVO, display, the TSI, the TVO, and HDMI DTVO. Cool. All right. Let's see what else we need here. So I think that was it pretty much. And then yeah, we will need to go ahead and like we will need to return and figure out this once we decide on what strategy we're gonna use to clone the other meta layers, because there are a couple. Like for example, you could use just Yocto Git sub projects and have all the meta layers in there. You can just kind of have them being cloned and maintained by Git and all that, which is very cool. And you can also use something called a manifest. That's how MediaTek does it. We will see. We might do it the same way they do, just to keep, everything the same. But I'm not completely sure, since I don't want to be maintaining that separately. So yeah, we will see if we can maybe. And also, one thing that I've noticed is, like, if you wanted to later add some sort of CI, pipeline to your Yocto build, with the manifest it gets a little bit more complex, because you will need to kind of like pull everything, and then like you will need to use the manifest, so you will need to install the tools for the manifest, and then you'll need to use the manifest file to pull everything in, sync against that manifest, right? So it gets a little bit more cumbersome. Whereas if you just use the kind of like the Gitsu modules, right, you essentially will have everything within your build machine right there available for you to build. So integrating Circle CI into this with some modules is a little bit more easier. So we might just go that route in order to later do a tutorial on how to do Circle CI, which I'm sure some of you guys might be interested. So let us know. Let us know if you guys want us to cover both cases. Let us know in the comments so that we can create another video, just kind of like covering the two different ways of keeping track of this. Keeping track of other meta layers we are using, or we can create that video and let you guys know. But yeah, just let us know in the comment. Cool. All right. So we're trying to do. Okay, so we're done with this. Well, I think after this, let's go ahead and just read our wiki here real quick. Because after write this, okay, we add the image recipe, and then we can create layer via bitbake. All right, create layer. Okay, this is another method for creating the layer. Okay, so next is just adding the basic image and then trying to compile. So we can either do that, or we can go ahead and try to build and just build a different image and see how that's gonna work. Now, the only reason why I'm hesitant about kind of like pushing this or just committing this and then moving to the next task is because I need to think what's gonna be the best strategy. So let's think. So like the thing is this: if we want to use some modules, we'll need to determine whether this is gonna be the path for the meta layers or not, right? So let's see if we want to use. So what? Okay, let's go ahead and check what they're doing here real quick. So if you see the instructions from MediaTek, what you guys will see is that they recommend using repo. And this is one way of keeping track. I don't know if you guys remember, but I mentioned that since Yocto is an open source project, you will pretty much constantly be having constant changes on the Yocto sources, right? Which is not great. Like, you might imagine that, or you might think that it's amazing because you will have kind of always up-to-date things. But the thing is that changes don't always work, right? And this is kind of like one of the downsides with Yocto is, like, if you have a very stable Yocto image and then someone else comes and push something into Yocto that then breaks your image, then you're not going to be happy. So one thing they need to do is keep track of all the layers that you're going to be using to a very, very detailed specific version of, like, for example, up to a commit, essentially. Like if you build your latest release and you use certain commit, then you know that is the commit that you're going to be using. You freeze that. So you freeze that in such a way that later, if someone else tries to replicate the build, they're going to be using the same commit, so that it's not going to break on production, right? That'll be very critical. So there's a couple ways of doing that. The way that they do it here, MediaTek, I mean, they do it with the repo approach, and the repo approach is pretty cool. It's actually pretty well known for in kind of the Yocto community, and it is a tool by Google called Repo. And Repo allows you to create a manifest file, which is an XML file where you define the kind of like the repos that you're going to be using. So and that's Git repos. So you find the Git repositories that you're going to be using. So the Git repositories where you're going to be pulling your meta layers from, and it defines what committer that you want to use or what branch you want to use. So you can sync them all to whatever you are actually comfortable with using. So what we can do is just go here, and this is the manifest file they use right on the MediaTek side. So this is the manifest file. Let's go ahead and once again, because the manifest needs to be synced with this specific branch. So what we're gonna be doing is we're gonna come here, tag it, or kind of like sync it to the tag that they're using on their wiki, just to make sure that we're using the latest one. And we're gonna take a look. So this is what I meant, right? This is a configuration file or the XML file that the manifest uses in order to pull everything and sync it to a specific version. So you can see here that some of them they are syncing just to a specific tag, in this case here, or there are some others that are even being synced to a specific commit. And you can do that with all the projects. If you can since as you can see here, there's a bunch of different meta layers that they require for building their demo layers or their demo images. So let's go through them real quick. So they have this that are synced to this specific tag are theirs, because that tag that Git tag is theirs. The release card gap v250. So these are repos that we should be able to find here in their Git directories. So for example, we have MetaReady. We already kind of like dig around that. MediaTek BSP, we already also play with that one. That's where we got our machine file from. Then we have the MediaTek TSN, MediaTek demo. That's also another one we know. And this Blue Droid one. And then they have these other ones, the MetaNN. That's for neural network stuff. And they have Pokey. They have ARM, Open Embedded, TensorFlow, Security, and this Metacylan one. So we'll need to decide whether we want to use this manifest version or kind of like this manifest approach, or if we want to go with the Git submodules one, because with Git submodules is more like they do it on NVIDIA. So if you go here and you check, for example, MetaTegra, let's go there and see. MetaTegra, no, let's go and see Tegra demo distro. That's the name of the. So if you go to Tegra demo distro, which is their kind of demo distribution for NVIDIA, you will see that what they do is they use Git modules. Like there's no repo here. What they do is they have this repos directory where we have all the submodules. Granted, there's less submodules in this build, right? And on the MediaTek one, but doesn't mean that we can do the same. The good thing about this is that kind of like as I mentioned, integrating this with CI is a little bit easier, at least from what I've experienced. But we can do both. And in this case, I think I'm gonna just go with I don't know. What would you guys think? Because if we go with the repo side, like the best practice is to create another Git repo just to host the repo, the manifest, just as they did here. This is a specific repository just for the manifest. So that's one thing we can do. And the other is just kind of like to have them be submodules, which should also be very simple, which is just kind of like us creating the repos directory in our local clone of our repo, and then we would essentially just clone all these repos and match them to a specific revision, and then we'll have Git take note of that in the Git repo stuff. That's good. Let's do it like screw it. Let's do it the Git way, just so that we can later do CI, social CI integration the way I know how to do it. Maybe you guys know a different way, and later, using repo later, and you can teach me. That's the beauty of the internet, right? So let's go here and say, okay, so let's do git status because we have some changes there that we haven't done yet. So what I'm gonna do is I'm gonna just leave the changes there, and let's do, so we have conf file. So let's go ahead and check once again metadata demo. So what they do is they have here the repos, right? And then they have a layers one. That's where they have the meta layers, but we can just leave it like that. Or maybe we can just create here the so let's create a directory called repos. Just kind of do a quick recap of what we were doing before we jump into that pause. We finished up doing the templates. We have them here, the BB layers template and then the local conf template, and we were gonna be deciding on what we were gonna do with the other meta layers were gonna be important, right? Because here in the BB layers conf, what we're gonna be defining are the meta layers that we're gonna require on a Yocto build, right? So not only our layers here, right? Because we have here meta p and mtk, but we also need other meta layers to be able to build a Yocto image, right? Remember, Yocto is like an onion, so you need a layer upon layer upon layer so that you can build your system the way you want it. So yeah, there's a couple ways we can do this. If you guys remember, there's the repo manifest one, and then get some modules. Either way will allow us to actually freeze our build and all the meta layers to a specific git commit hash, which makes it very easy to maintain, and then also makes sure that if we rebuild this on a different environment, on a different computer or something, it's not gonna break because some random people, are committing stuff into meta layers you guys are using. So this is very important. We're gonna go with get some modules, mostly because this makes very easy to integrate with GitLab, with Git CI. So if you want to automate it, like to automate building your Yocto images on GitLab or in some sort of CI, pipeline type of framework, in our experience, that's the way we've done it. So we're gonna do it this way, and then if you guys want us to do it a different way, like with repo instead, just let us know down in the comments, and we can definitely jump on and do a video on that. This is even like this might require a whole video on its own, but yeah. So before we do that, actually, since I already recorded this a couple times, I know beforehand that we're gonna hit an error. So let's go ahead and fix that, because that's gonna be a little bit more clean on our Git history. And that error is actually with our machine. It's a very simple error that is gonna stop you guys from building. So pay attention to this, right? So if you hit an issue where once you start building where this where the machine is not building because of this includes, this is the fix to it. So pay attention to this, and we're gonna avoid that issue right from the get-go, right? So the issue here is essentially that since we're including MT8370 and MT7921 from MediaTek's meta layer instead of ours, we cannot include that as if it was local to us. So we need to include this with conf machine include, with conf machine before the include part, right? So that Yocto is able to find this in the kind of like the global Yocto environment instead of trying to look for this locally in our meta layer, because it's not gonna find it. So that's all. That's the fix. Cool. All right. So I'm gonna go ahead and push this. This is why I rather do it at the very beginning, is because it is very easy for us to do. For example, if I do a git log real quick, git log. So git log real quick will show us that the last commit was actually at base machine. So we can very easily just amend this commit so that it has now the proper machine configuration, and Git history is going to be nice and tidy. So I'm going to go ahead and do git add, right? Well, git status will show you that we only have a modification. So if we git diff, it'll show you the small change we did. So I'm going to do git add -u for just kind of to add the on stash stuff. So I'm going to do git status once again. Oh, the on stage stuff. So yeah, that shows that now we have staged our change on the machine configuration file. We're going to do git commit amend, right? That is going to fix our add base machine commit. It's going to ask us for the password. That's because I have set it that way. And yeah, that's it. So we already have fixed our machine. We're good to go. So let's go ahead and start adding our repos. If I'm going to do is like, if I do an ls, all we have is the configuration directory where we have all the configuration for our custom meta layer, and then we have the readme. What we need to do here is actually just add a new directory where we are going to be storing our repos. I'm going to name that directory repos, right? Super creative. All right, cool. So let's go ahead and do mkdir, right, for make directory. We're going to do repos. We're going to be storing everything, like all the repos we're going to be getting. All the submodules are going to be stored there. So let's go ahead and do that. The way we get the submodules is very simple. So we go to the default XML manifest here from MediaTek. Remember to set the proper branch. Where you can get this very easily, you just go to MediaTek's Wiki, and if you find where they start kind of like the configuration for everything, they get you here to sync kind of like your build to this Git repository which contains the manifest, and then they require this repo to sync it up to this branch specifically. So that's what we're going to be doing. So we go here, right? This is the repository. It's already synced to that ScarletGap branch, which is very important. And then this manifest, if you guys see, is just an XML file which contains all the repos that you're going to be requiring for this build, or at least according to what MediaTek requires you to have, right? At least to build their demo image or their demo meta layer. Plus, it's going to specify the specific versions. There are some repos in here that are going to be kind of like revisioned by a branch or a DAC. And then there are other repos in here, like for example this one, which is actually revisioned by a git commit hash. So if you see here, like this is very, very cool, because like for the commits that you're going to be revving or kind of like freezing to a specific commit hash, like there's no way someone will go and push a new commit and it's going to break your build, because every time you build and you use this, it's going to sync it up to that specific commit hash that you know it works, right? So that's what's cool about Git. And then for the ones that actually use this other way of syncing, it's not a branch, it's actually a tag. So that's very important, because the difference between a branch and a tag is like once you tag something, is tied to a specific commit. If you use a branch, then you're also vulnerable to someone else pushing to a branch and breaking your build. So using a commit tag is better. Since these are commit tags, because we already know from the work we've been doing, we're completely fine. So let's go ahead and start adding the commit submodules. Well, the Git submodules, they're actually very easy to add, but I forgot the command. So I'm gonna just go ahead and Google here real quick how to add submodule, because I forgot. I think it's just git submodule add, and then I think it's just git submodule add the submodule and where you want to add it. But let me just find something to reference of use as a reference. So here, for example, this is git submodule add, then the kind of the link to the repo you're going to be adding as a submodule, and then the location, right? So we now know that this is going to be repos for us, and then whatever name we want to use for that specific submodule. So this is going to be very repetitive. We're going to go ahead and start. Let's go ahead and do first you can see here on the remotes, you have multiple definitions. So you have one for Ready, one for Yocto, one for Open Embedded, and one for GitHub. So Ready are the ones from MediaTek. The other ones are very much just Open Embedded stuff. So we're gonna start with the Yocto ones, then Open Embedded, then GitHub, then we can do Ready, which are the kind of like the more custom ones, right? Because it's custom to your to the boards that we're gonna be using. So that's just a nice order to follow, I guess. So yeah, let's go ahead and do that. So really fast, what we're gonna be doing is I'm gonna just Control F here this for just to make it easier on myself, and then we're gonna start by copying or by cloning Pokey or adding Pokey as a submodule. So this is gonna be very simple. I'm gonna go ahead and copy the remote, here. So I'm gonna copy the remote, Control C. So I'm gonna go here, and then I wanna do, well, let's see, we already created the repos directory, very important. So I'm gonna go git submodule add, then the remote, then / and I'm gonna add here the name of the repo, right? This is the name of the repo. It's gonna be pokey.git. So I'm gonna copy that, paste it here. Then I'm gonna specify where I want this submodule to go. So I already know that I want this to go inside repos, and I want this to be named Pokey, right? I don't want to change the name of the repo, of the GitHub repo. So I'm gonna go ahead and run this. Let me see, locally with remotes. origin. Okay, so this is mostly because I already added this before. So yeah, this is not gonna happen to you guys if you're gonna be doing this from the first time. This is just because I'm doing it, you know, calling third time now. So I'm gonna go ahead and just force it so that we reclone everything and you guys can see. But you should be able to run it without the force parameter, right? So I'm gonna do force. What's that? So I think I need to add this in the git module, add dash force. Nope. How's it that we use this? Let me learn this real quick. So use the force option. So I guess it goes here. Git add dash force. There you go. So now if we go into repos, pokey, I do ls. So we are already here. And you see, like, this is already detached at the commit hash. That's because Git history already knows this, because I already did this before. So what I'm gonna be doing is I'm gonna go ahead and redo this for you. If whenever you clone this, probably it's gonna be like something like this. It's gonna be checked out to master, for example. So it's gonna be checked out to master. It's gonna look like this, right? It's gonna, like, if you do git branch, it's gonna show that's on master. And then what we're gonna be doing is actually making sure that we match, or that we sync it up to that specific git commit hash. So I'm gonna copy this, I'm gonna git checkout, right, the commit hash, and so it's gonna say that blah blah blah. We're gonna be detaching our head to a specific commit hash. That's okay. So I'm gonna just do that. I'm gonna go back, then I'm gonna go git status. Let me see what changes, what changed here actually. So yeah, okay, cool. So now I think if I go back, let me see, ls dot. So now we have actually, it gets some modules. And see, we have pokey here. All right, so I don't know why was Kit complaining before. As I mentioned, that was because I'm already doing this for kind of like the third time, so that's normal to me. But for you guys, it shouldn't be that way. But like either way, you see that if it happens to you guys, you can just use the force option right after that, and it should work regardless. So I'm gonna go ahead and continue adding the other repos here. So the next one's gonna be meta arm git, right? So we're gonna do just the same. We're gonna copy here this part. We're gonna go ahead and do let me look for that command. So it's gonna be something like this. Probably it's gonna require the force, so let's just try it for fun, right? And we're gonna change pokey.git for meta arm git, and we're gonna be cloning this. Is instead of pokey, we're gonna be cloning into meta arm. So if I run that, so same thing, it's gonna require the force. I think I'm just gonna use the force either way on all the from now on, right? So if I do force, then it reactivated the modules there. If I do ls, if I go into repos, I should be able to go into meta arm, and we already synced to that specific commit. If you see here, that's because I already did it, but you guys need to actually do this, right? So git checkout, the commit hash, it's already there. So go back, then you go once more back until you are on meta pnmtk, and you run the same command for the next repo, right? In this case, it's gonna be meta tensorflow.git. So we're gonna look for that handy dandy command, right? And we're gonna be pasting, instead of meta arm, we're gonna be using meta tensorflow git instead of meta arm. Here it's gonna name meta tensorflow, right? Then we're gonna go into repos, meta tensorflow. It's already synced to this commit, but for you guys, it's not gonna be synced there. It's gonna be synced to master or something. So make sure to run git checkout the commit hash, right? It's already attached there. So we're gonna go back and then go back, and then we're already here. So we're gonna do the last git repo for pokey, which is gonna be meta security. Oops. Okay, so meta security, we're gonna look for that specific, for the git modules add command. We're gonna change meta tensorflow.git for meta security. Notice that in this case, it doesn't have .git. That's okay. That's how the repo is named. It works for us either way. So we're gonna rename this to meta security. We're gonna go into meta security. It's already synced to BZ865C5. So this is right here. So if you guys see here, it says BCA6, so it's already synced there. That's because I already did it. Once again, you guys just need to do it. It's just git checkout the commit hash. You're good to go, right? Cool. All right, so that should be it for the Poki repos. Now let's go ahead and do open embedded. I think this is just gonna be 1 or 2. Oh yeah, 1. So that's very cool. We're just gonna go ahead and copy this remote. So Control Z. Then we look for the git module add command. We paste it here instead of the Poki remote, right? We add a /. Then we look for the name of the repo, which is going to be meta open embedded, right? That is very important. Then you're going to place it here. Then instead of meta security, it's going to be meta open embedded. So it goes ahead and reactivates it for you guys. It's going to clone the repo and all that. So if I go into repos meta open embedded, it's already synced there. So I'm going to just go ahead and redo the git checkout, right? And that's good. So I want to go ahead and cd ls. So we are right there. And then we just need to do the GitHub one, which is just one. Once again, I just can like copy here the remote link, right? Look for the submodule command. Let me try to find that. So here I just delete what was there. Oops, I messed that up. So yeah, remove the open embedded one. I'm gonna paste the GitHub one. I'm gonna come ahead and copy the name of the repo. Notice this, like this time already changed. Also, it's crash meta clang git. So I'm gonna go ahead and copy that, right? And see how they moved it into meta clang instead of using the crash or kraj /. So they removed that part. We're gonna do the same because this is already accounted for on the baby layers configuration file. So we're gonna be doing that. So yeah, I wanna be pasting that here. And right here, instead of doing meta open embedded, we're gonna do the same meta clang. So that's it. I'm gonna go into repos meta clang. It's already there, but I'm gonna do it either way. So git checkout. Remember guys, this is very important step because if you don't do this, then it's gonna be synced to a branch instead of a commit hash. So if someone goes and pushes into those open source repos, then your build might break, right? That's the whole point. Like that's the reason why we're doing this. So let's go ahead and go back. And I think we're ready. We're now ready to actually do the ready ones. So those are a little bit more, but it's okay. We're gonna push through them real quick. So we're gonna go ahead and copy this. So Control C. I'm gonna look for the git submodule add, right? I'm gonna remove the remote, add the ready remote, and make sure that we start doing the repos one by one. So I'm gonna start with meta ready. I'm gonna go ahead and paste it here, meta ready. Instead of meta clang, I'm gonna do meta ready, right? Then I'm gonna go into repos meta ready. If I do ls, I already have everything here, right? Because GitHub's already syncing it up. But you know, just as I've already mentioned a couple of times, you guys need to actually sync this. So the way you do that is you just go ahead and sync it to this tag, I think. So you just go ahead and do redis cargap v250. So Control C, right? And do git checkout redis cargap v250. Right, so it's already synced there. I'm gonna go ahead and do the other ones real quick. So it's gonna be meta MediaTek bsp.git, right? So copy that one up, look for the git submodule add command. I'm gonna remove, oops, I think I removed too much of it. So I'm gonna go ahead and redo that. Oops. Git add force. So we need to recopy the remote because I don't know what it is. So I'm gonna just copy that, paste it here, right? No biggie. Reading /, then we go ahead and copy meta MediaTek bsp git, right? We paste it here. It's gonna go ahead and copy that. I'm gonna do this just fast because I already have them, guys. But well, I'm just gonna do it the right way. So I'm gonna go into meta repos meta MediaTek. What's the name of it? Oops, I think I messed that one up, because do you see guys that are here? I ran the command but didn't change the repos meta-ready, so I forced cloned my MediaTek BSP into meta-ready. So that's an issue. So I'm gonna go ahead and redo that. So I want to go ahead and try to fix that. So I'm gonna run this, right, because I wanna link once again meta-ready to repos meta-ready. Then so I'm gonna go ahead and go into repos meta-ready just to make sure that we are synced there. So yeah, we're synced to the tag. When I go back a couple times, I want to rerun the MediaTek BSP, but instead of repos meta-ready, I want to change that, right? That was my mistake last time. So I'm gonna copy this, I'm gonna paste it here, and I'm gonna remove the .git. So I'm gonna be cloning MediaTek BSP into MediaTek BSP, which makes sense. So I'm gonna go into repos MediaTek BSP. It's already there. It's card cap v250. Cool. I'm gonna run the command to sync it up just in case. That's okay. So you can check out. Boom, that works. So I'm gonna go ahead a couple directories up, and then I'm gonna look for the next one. So the next one is actually MediaTek tsn.git. So I'm gonna copy that. Once again, remember to change this. That was the issue last time. And then I'm gonna change it here too. It's here. There you go. See repo MediaTek tsn. It's already there. So I'm gonna just go ahead and run the git checkout to the specific tag. Then go back a couple times right here. And then I'm gonna do MediaTek demo git. Control C, right? Git module, change this, then change this real quick. There you go. CD repos should be here. Then if I run the git checkout, it's already gonna be there, but it's okay. I'm just running for you guys so that I can feel the pain. But yeah, so I'm gonna go ahead and copy the next one, which is gonna be MediaTek Blue Droid. We're almost done, just a couple more to go, and we're gonna be done. We can start building, which is gonna be very exciting. That's the kind of like the best part, right? Of creating your custom Yocto. It's actually have it built and then test it. So yeah, I'm gonna copy this here. I'm gonna go into repos MediaTek Blue Droid. I'm gonna sync it up with the git checkout. There you go. Then we go back a couple times, and then let's do the last two. This is very exciting, guys. Very exciting things gonna happen. And yeah, this is the longest tutorial we're gonna do, I think. And then from now on, we're gonna do smaller ones, but they're gonna be packed with information. So I know you guys are gonna enjoy this very much. Hope you guys enjoyed at least half of what I'm enjoying actually making them. But yeah, so let's go ahead and do this. I wanna this is almost the last one, so I'm gonna change here meta neural network, very important, right? So reactivating cd repos meta nm. I wanna do this is very cool. I can do control R git checkout, right? That works. So I'm gonna do this. It's already there. Yeah, cool. So I can do ls, right? No, sorry, I can do the last one. Okay, cool. Meta security from Brady. So, oh, well, no, actually this I don't need to do. I already done this. It's just because it is named meta security. It is actually finding it because of the ready. That's cool. So we're already done. Very cool. Now, guys, what we can do is actually, well, we're going to git status real quick. As you guys can see, now we have the modules, and then all the modules cloned and checked out to a specific version that we actually want to use. So what we're going to be doing is we're going to, of course, we're going to be pushing this so that we can keep track of it and our git history. So we're going to do git add, right? So we're going to do git add -u, right? Git status. Then we're going to be doing git commit -m. And I want to add git submodules. I want to assign the commit, right? Then we're going to git status once again. Now what we have are the templates. But what we can do before pushing the templates is actually trying to go ahead and build and see if the templates work. That's going to be the best part. So if I recall, I already tried to do that. So what we're going to be doing, just kind of to recap it, is we're going to go ahead and look for this command, export template conf. This command will let Yocto know where to go and grab the templates from. So we're just going to do Control C, Control V. So now we just need to go ahead and build our Yocto image. Let's see if that works. First thing we need to do is we need to go ahead and define the templates. Well, it's not defining templates per se, but it's telling Yocto where to find the templates, right? Once Yocto knows where to find the templates, you can just run the bitbake tool, and that's going to be creating a whole environment for us to bake our image. So let's go ahead and copy this from the MediaTek Wiki. Then we're just going to define our conf directory here. Once that's done, all we need to do is just use source, just to run a tool that is inside of Poki. We now know that Poki is inside of repos, Poki, and the tool is called OE init build env, right? And that is for open embedded, initialize the build environment, right? So we are telling Yocto to initialize the build environment. This you will need to do every time you open a new console, right? So essentially, if you do this once and then you don't close your console and you want to rebuild multiple times, then you can just run the bitbake command without having to do this initialization. But then let's say that, I don't know, that's late at night, then you turn off your computer, you want to start back again next day, and you open up a new console, so you will need to set up this again, the environment. So the environment is set up kind of like for the whatever the console's I don't know, like cache or memory is defined for, right? So we're gonna run this for our first time, and then so it says template conf value conf. Okay, so it needs to point to the actual template name. So what we're gonna do is change that for conf. It's gonna be inside templates, and then it's gonna be named default. So let's just do that, and then run the source repos poki init once again. What the heck is now non-existent directory default? Let me double check that. So it should be conf templates default. So yeah, it's in there. So I guess it is just because we are not defining the full path. So what I'm going to be doing is I'm just going to say, okay, just use pwd, right? Pwd. And then let's cat that. Let's just echo that. So let's do echo, and let's echo template conf, just so that we know what the actual value of that variable is. All right, so it's now full path. That's cool. Let's go ahead and do the source once again. So it's initialized already. If you guys see here on the screen, is now we are working inside our of a new directory called build, right? We didn't create that directory. bitbake did it for us, or at least the initialization script did it for us. So now we can just run inside of this build directory all our commits related to bitbake, or not commits, to all our commands, right? So for example, if we want to start building our Yocto image, we just need to run a simple command, which is called bitbake, right? So we're just gonna do bitbake. Then we're gonna bake an image called, I forgot the name of the image actually. So I'm gonna go ahead and come here to MetaReady, right? And then I wanna remember the name of the actual image that we're gonna be building. I guess it is this one, MetaReady demo. I'm just gonna go ahead and check. So recipes demo. So yeah, the name of the image is ready demo image. So we're just gonna bake that image because we didn't have a custom image yet, right? Stay tuned for the next episodes. In there, we're gonna show you how to build custom image. So bitbake ready, right, dash demo image, and that's gonna start the bitbake process. Oops, or it's gonna fail. So it says user namespaces not available by bitbake. All right, so this issue is actually a known issue, I think, for Ubuntu 24.04, which is the one that I'm using. This is right here. So this command right here, the sudo app armor parser -r, etc., blah blah blah. That's a command that's gonna save your life in this case. So I'm just gonna run that. It's gonna ask you for your password. So I'm gonna try to not mess that one up. I think I already messed it. No, I didn't mess it up. Cool. So I'm gonna just rerun the bitbake command, and hopefully now we get another error. So let me see. It's time to check your potential misconfiguration. Is invalid. Please set a valid machine on your local conf. That is interesting. MKT. Okay. Now I see what the error is. and it is actually like a typo on the configuration file. So if I go to local.conf and I go to the machine definition, so we are actually defining the machine as MKT G510. And if you guys recall correctly, our machine is actually called MTK, right? MKT doesn't really make sense. So first of all, you guys need to go ahead and fix the template. But one thing that you can do, which is actually what I usually do whenever I build a Yocto image, is I just set this environment variable at the very beginning. So I will just do MTK right here, so that we can just kind of like go over this and have this build. And there you go, voila, it starts building. So yeah, now Yocto is building. It's gonna take hours, right? And then later I will just kind of go ahead and fix that. But please go ahead and fix it on your builds, guys, on your custom meta recipes. We can just, well, actually we haven't pushed the templates yet, so I'm just gonna head and fix it. So MTK, right, instead of MKT, and that should fix it. And then well, that's already building, so I'm just gonna open up another console. Let's see if I can do that. Control Shift D, Control Shift O. So yeah, Control Shift O. So I already have this here. Git status. We haven't pushed yet the template, so I'm just gonna do git add conf templates. Oops. No. Oh, okay. I'm setting build, so I'm just gonna do git add conf templates. Git status. Okay. Git add conf templates, and then default git status. Then we're gonna have the templates that we need to add, so I'm just gonna commit that. They're already fixed. So if you guys go to the repo, which is public, you should be able to find the proper config. But if you were following the tutorial, just make sure to fix that for later usage. All right, if you just set the environment variable on the command, on the bitbake command, it should work for you just as it is currently working for us right here. So I'm gonna just do that, then git commit -m add template files, right? Or template config files. And there you go. So I'm just gonna sign the commit. I'm gonna exit this terminal. Now we have actually Yocto trying to build here. You might find issues, like depending on your network connection. For example, Yocto might say, hey, we cannot fetch whatever, then it's gonna break. You can just rerun the bitbake command. It's gonna pick it up from whatever it was. And then also, if you are currently building, and since this takes too much time, right? For us, it takes like 4 to 6 hours. So you can just, and you need to go and do something else with your life, then you can just Control C and have it exit in a clean way, right? So Yocto is going to try to finish up all the processes that it has currently running. It's not going to start any other process, and it's going to close gracefully, right? And if you are in a big hurry, you can just do Control C. That is going to kill Yocto, but that might cause issues later on that you might need to kind of clean stuff, or just to restart the build. But right now Yocto is building, so thumbs up for us, right? So yeah, hope you guys enjoy it. This is the end of this tutorial right now. I know it's a long tutorial. It's our first tutorial, so please bear with us as we get better at this. But I hope it's helpful for you guys. Hope you guys learned a lot. We enjoyed a lot kind of recording this and making it. Stay tuned. We're going to drop our next tutorial very soon. We're going to be working on custom image. Then we're going to show you how to flash the MTK. And we're the plan is to continue building these tutorials and start showing you guys more and more stuff, like how to run GStreamer pipelines, how to add stuff into your Yocto image, how to run AI, right? So all that cool stuff we're going to be showing you guys down the line. So stay tuned, please subscribe, and yeah, let us know what you guys want us to do with our MTK G510 in the future. Thank you guys for watching. Please have a good one. Bye bye.